So now we will see what are the non-functional requirements. The accessibility requirement. Accessibility requirement, it is viewed as the ability to access, because if we have built some system, then it should be accessible to the people. So we have to make an assurance that the system has the accessibility requirement. So the benefit is that if some entity wants to access the system, they should be able to access. The concept focuses on enabling access for people with disabilities, special needs, or enabling access through assistive technology. So what does it cover? It covers different levels, like levels of blindness support. So it must be able to increase font size or type to assist with the reading for affected people. If we open any system, so we should be allowed to change the font size, type as per our requirements. Then comes the level of color blindness support. So it should be able to change the color palette to match the individual requirements, so that the color blindness people will also find the system useful. Then the use of voice activated commands should be allowed for disabled people. So it must be able to use the voice commands for individuals that cannot type commands or use the mouse in normal case. So these three levels of assistive technology is required in the system. There should be a support for blind people, people with color blindness, and disabled people who cannot type the commands. So they should be able to give the voice commands. Now, audit and control requirements. Audit means the ability to investigate the use of the system and report any violations to the system's data and processing rules. That means we should be able to audit the entire system to find out if there is any violations in the system. Now, the control requirement is that we should be allowed to control the system. We should be able to ensure that the system is used in the manner in which it was pre-approved to be used. And if there is any discrepancies, then we should be able to know that who is using the system. Now, this approach is called as the role-based access control. So it's mostly used as an approach which will restrict the system and allow only authorized users to access the system. So we can have an access matrix and we can have the various rules. If a user is allowed to access a particular role, then it will be mentioned in the matrix. So every time when a new user comes to the system, the user's role will be verified, and whether the user is having access or not will be checked, and accordingly the access will be provided. So it's a very simple technique. Using the role-based access control, we can control the person who are accessing the system. Then comes availability requirement. So how much time the system is available, we should be able to calculate it, and we should be able to make the system available for most of the time. So it is the ratio of the expected uptime of the system to the aggregated of the downtime of the system. For example, your business hours are between 9 to 17, and you cannot have more than 1 hour of downtime during your business hour. So we require 87.5% availability. That means out of 8 hours, 7 hours our system should be available. That means 7 by 8, that is 87.5%. If suppose our system should be available from 10 to 6 and it is allowed that 2 hours there can be a downtime. So out of 8 hours, 6 hours the system should be available, and accordingly we can calculate the availability. Now, backup requirement. A backup requirement is the process of backing up, refers to the archiving of the data lake and all the data science programming code, programming libraries, algorithms and data models with the sole purpose of restoring these to known good state of the system after the data loss or corruption event, because we should store the different states of the system. If there is any error, fault, corruption, then in that case the some data might be lost, but we should be able to back up or roll back the system to a particular safe state. Capacity, current and forecast. So what is capacity? Is the ability to load, process and store a specific quantity of data by the data science processing solution. So we must be able to keep track of current and forecast the future requirement, because as a data scientist you will design and deploy many complex models that will require additional capacity to complete the processing pipeline, to create your own processing cycles. So we should be able to find out what is the current capacity of the system, how much load the system can take now, and we should be able to forecast the future needs of the system. Capacity is measured as per the component's ability to consistently maintain specific levels of performance as the data load demand vary in solution. Example, the data hard drive will provide 95% capacity for 1000 users, each with 10 MB of data during a time frame of 10 minutes. So in this way we need to specify the capacity, that if there are 1000 users and each user will be provided a 10 MB data during a time frame of 10 minutes. This is how we measure the capacity of the system during high demands. Then comes concurrency. So concurrency is the measure of component to maintain a specific level of performance when under multiple simultaneous load conditions. So if there are if many users are using the system at the same time, definitely if it's a multi-user system, concurrent processors are using the system, so how the access will be provided during heavy loads, this also should be specified. Like we can like for example, the memory will support a concurrent group of 100 users running a short algorithm of 1000 records simultaneously. So at one time 100 users can run a data sorting algorithm of 1000 records. Throughput capacity, it is like how many transactions at the peak time of the system requires to handle a specific condition, or how many transactions can be completed, that is the throughput capacity of the system. Now storage memory, this is the volume of data the system will persist in memory at runtime to sustain an effective processing solution, that how much data can be brought into the memory and it can be processed at the runtime, so that we'll be able to effectively continue with our processing of data science project. Storage on the disk, this is the volume of data the system stores on the disk to sustain an effective processing solution. So all this needs to be defined, like throughput capacity, storage capacity on memory, storage capacity on disk. Now storage in GPU, let's see it in the next video. Thank you.